Alright, looks like we're going. Looks like we're rolling. Alright, I'm gonna wait for some people to get in and then we'll start. So I haven't done a lot of these middle school ones since since I was in middle school. And so I'm hoping that there's no like brand new like super weird questions that come up. But there might be. You don't know. But if the so because it's a middle school, like the beginning of the test is just a lot of arithmetic, or at least that's how it was when I was doing it. And so we're not just gonna solve every single question. Instead, I'm just gonna do this based on questions only. I have it set up in the description where you can access the test if you want to. So we're just gonna do this based on request, and if it's a while before people start having questions, uh, then I'll just end it on the stream. Unless you guys just want me to go through it, you could also do that. I might just start. I might just start at the beginning. A little bit of background. Yeah, I forgot how annoying these were. Okay, you want to see question 22? I can do that. Oh, yeah, this one is pretty annoying actually. Oh, I was glancing over right before I did this, and this was one that I was like, wait, what's going on here? All right, let's see. Um, the first thing that I tried was I just tried adding all these up. I was basically just looking at 89 and trying to find a pattern. So if I just add, excluding the 89, if I add up all the other numbers, right? 7 plus 8 is 15, plus 9 is 24, plus 9 is 33, plus 6 is 39. Did I do that right? 18 plus 6 is 24. Yeah, yeah, it's just 39. And I didn't really know what to do with 39, so I kind of just moved on, right? So if I add up the ones for the 91, I get 4 plus 5 is 9, plus 8 is 17, plus 13 is 30, plus 11 is 41. And this is where I kind of saw what was going on. So you see, to go from 89 to 91, that's just plus 2. And 39 to 41, that's also just plus 2. And so this pattern's a little weird. It's kind of annoying, but the reality is it's just the sum of the outside. And then let's see, 39 to 89, 41 to 91. It's just that plus 50. So let's see, for this one over here, 10 plus 17 is 27, plus 4 is 31, plus 9 is 40, plus 3 is 43. And then add my 50, you get 93. I wish the pattern was a little bit better, but I wonder how much variety do they have on these kinds of questions? I bet it's pretty varied actually. That was the one thing I remember about the regional test. They would always throw some weird stuff at you on the regional test. Okay, let's see. What's another one that might be tricky? Oh, I remember these. Do they still ask these? What's the sum of the letters in the word calculate? I had a way of doing this. Oh yeah, I remember. It was Can I just go in order? Yeah. I'm looking at 16 because I remember this, and there's a way that I would remember these. I use this like it's not really an acronym. It's just kind of a word, but not really a word. And I use these to memorize like 5, 10, 15, 20, and 25. And then if I could do this, then it was a lot easier to find out what these letters were. So for example, like C is pretty easy. C is just 3. So that's 3. A is just 1. And then L, if J is 10, that would make L 12. C is 3. If T is 20, then U would be 21. And then L is 12 again, and then A is 1, T is 20, E is 5. Right? So it makes it a little bit easier. If you don't, I mean, if you just have this memorized, then that's perfect. But this is what I started using. Okay. Uh, I think I'm just going to go in order. I'm going to skip over these. I'm going to skip over these ones because you don't really need me to do that. If pi equals 3, what's the radius of a circle with circumference of 102 inches? Right? So C equals 2 pi r. Yeah, and if that's equal to 102, and I'm setting pi equal to 3. So 2 times 3 times r is 6r equals 102. So I get r equals 17. All right, square root of 811 lies between which pair of integers? It'd be good to have some like perfect squares memorized for this one. So off the top of my head, 27 squared is 729, and 28 squared is 784. 29 squared is 841. And so the square root of 784 would be 28 then, and the square root of 841 would be 29. And so square root of 811 would have to be somewhere in between 28 and 29. So for that, you would really just have to have some perfect squares memorized. You could either that, or you could actually just square these ones and see like, oh, which one of these answer choices has 811 in between those two. But yeah, you should have those perfect squares memorized to 30 anyway, probably. All right, so what is the product of the sum of the, oh my gosh, product of the sum of the number of edges and faces of a rectangular prism and the sum of the number of edges and vertices in a hexagonal prism. Okay, so this is the product of two things. Okay, the wording just tripped me up a little. Edges and faces in a rectangular prism. Okay, so how many edges are there in a rectangular prism? It would be the same as a cube, right? So that would be 12. And how many faces? That's just, you got 4 on the outside and then 2 bases, so that's 6. And then the sum of the number of edges and vertices of a hexagonal prism. Okay, so you got 6 on each base, and then you got 6 on like the lateral parts. So you have 18 edges on a hexagonal prism, and then vertices, you just have one for every corner of a hexagon. And so you have 6 on a hexagon, and you have 2 bases, so that's 12. So this is just 18 times 30. It's 540. Nice. Okay, let's see. What's the GCF of 12, 16, 26, and 38? Off the top of my head, it's looking like this is going to be 2. But we can divide just to make sure. So if we divide everything by 2, we're going to get 6, 8, 13, and 19. And yeah, and 13 and 19 are both prime, so we're not going to be able to find any other common factors. So it's just 2. Number 9, it's looking like we can group some of these together. So it's 9 plus 10 minus 11 plus 12 minus 13. It's looking like we'll be able to group some of these. And see, because they're consecutive, these are all going to end up being -1. And so it would be 9 minus 1 minus 1 minus 1 minus 1, and then plus 18. So 9 minus 4 plus 18 gives you 23. If I'm going too fast, or you want me to go back to say something? Or if you think of one that you want me to skip to? Alright, which of the expressions matches 6 less then twice the sum of three numbers. So twice, okay, the sum of three numbers, that's just a plus b plus c. But then I have twice that, and then 6 less than that. So, oh, it's C. I just didn't see it. Is there a trick to find faces or edges of any shape? Let's see. For prisms, it's pretty easy because, here, this will be easier if I show you. But you see how, so this is a hexagonal prism. So you're always going to have two on the top and bottom. So sorry, you're gonna have one on the top and one on the bottom for a total of two, right? And then you're gonna have faces like on the outside of your prism, and the number of faces will be the same as the number of sides in the shape. And so I guess you could say for like an N-shape prism, you would have N plus 2 faces. I guess you could say that. So like you would have N faces for the lateral parts, right? For like that and that and that and going all the way around. And then you have the one on the top and you would have the one on the bottom. So that'd be how many faces. And then you can see the only vertices that you get are whenever these faces intersect with the hexagon on the bottom. And so I'll get 6 vertices on the bottom and 6 vertices on top. So, I mean, if you wanted to have a formula, you could say we 2n vertices. And then for edges, let's see. Okay, so you're gonna have 6 edges on the sides. Sorry, on the face, like on the hexagon, the 6 sides will be 6 edges, and then same thing on the bottom. And then you're also gonna get 6 edges going like up and down. So I guess you could say you would have 3n edges. Oh, there's also another thing. There's this formula called I think it's called Euler's formula. I mean, Euler has like 100 formulas, but you know, but it says that if you have the number of faces, the number of faces plus the number of vertices equals the number of edges plus 2. This is a good formula. If it tells you like the number of faces and vertices in a shape, then you can use it to calculate the number of edges or some other combination. But you can kind of confirm this right here, I guess. So like F would be n plus 2, V would be 2n, and then equals 3n plus 2. And you can see this is true, right? 3n plus 2 equals 3n plus 2. Hopefully that answers your question. So I guess yeah, you can use a trick, but it really just comes from like from visualizing the shape. And this is only for prisms, I should say. Right? Only for prisms, because other shapes get more complicated. This right here, this formula that I have here, this is for any three-dimensional shape. So like tetrahedrons, dodecahedrons, but then also like any kind of prism you can think of. Okay. I'm gonna skip 11 because it's just multiplication. I don't really want to do it. I think this is B though. If I'm doing that right. Yeah, 5776. Okay, what is the value of x in the picture below? Let's see. So this angle right here would be 180 minus 119, which is 61. And then this angle, oh, okay. This is a little bit of a shortcut you can do here. So to find this angle, which I will call like A, to find A, you would do 180 minus 87 minus 61. Right? This is what A is. Because there's 180 degrees in a triangle, and you have these other two. So that's what A would be. And then whenever you solve for x, x would just be 180 minus A, right? And so if x is 180 minus A, then if I rearrange this a little bit, I can see, if I subtract the A over here, add these over here, I can see that to find 180 minus A, which is the same thing as x, I can actually just add these two angles. I think there's a name for this theorem. It's called like exterior angle theorem, maybe? I feel like I just made that up. But anyway, you can do this. 87 plus 61 just gives you 148. Okay, 13. Basically, so it looks like it gives you a function, like it defines a function for you. So 8 and 5 would be 40 minus 8 plus 5 equals 37. Yeah, I questioned myself there for a second. And then it would be 37 heart 7. So 37 times 7 minus 37 plus 7, which gives you 229. Yeah. Okay, let's see. Centimeters to hectometers. Okay, so this is just an exercise in moving the decimal, really. So if I wanted to convert this to meters, I'd have to divide it by 100. And so it would be that many meters. And then there's 100 meters in a hectometer. So I'm going to move this over 2 more times. And so I get 6,500 hectometers. Let's see, Connor starts with $300. He gives 65% of his money to his friend Fred, and then Fred gives his mother 20% of his money. How much money does Fred's mother receive? So he has $300. He gives 65% of his money to Fred. Actually, I'm going to write this as a fraction because it might make this easier. Instead of 65%, I'm going to write it as 13 over 20. I might be able to cancel some stuff. And then Fred gives his mother 20% of his money, so she is getting 1/5 of that amount. So if I do it this way, oh yeah, this does make it easier. So if I multiply these two fractions, right, I get 13 over 200, or sorry, over 100. I saw the 2 and just went with 200. So you get 300 times 13 over 100. Well, 300 divided by 100, I can cancel that and just get a 3. And then 3 times 13 is 39. We already went over 16. Let's see, 51 nickels plus 17 quarters equals how many dimes plus 440 pennies? I mean, yeah, this one's just like this, minus 440, and then divide everything by 10. So let's see, 51 times 5 is 255 plus 17 times 25 is 425, so that's 680 minus 440 gives us 240, so 24 dimes. Number sense really does help with math. So if you're doing math and you're thinking like, oh, how can I boost my game in math? You should really try taking up number sense. Okay, what is the sum of the lower quartile and upper quartile of this set of numbers? All right. First thing I have to do is I just have to write these in order. So 17, 21, I get cross-eyed a little bit. 39, 40, nope, 43, 44, 52. Is that right? Are there only 6 numbers? Yeah. Do question 61. You know, I would try. This is actually a middle school test if you didn't know. This only has 50 questions. I was like, wait, I'm missing something. I only have 50 questions. And then I realized, wait, this is a middle school test. I got used to high school. What can I say? All right, so the lower quartile and the upper quartile. Okay, so to find these, first thing you have to do is find the median. Or you don't have to find the median per se. You just have to know like where it is. So because I have an even number of numbers, my median is going to be between 39 and 43. It's going to be like halfway in between here. So it's going to be 41. You don't have to know that it's 41. Um, but the reason I put this is because the lower quartile is like the median of the lower half, and the upper quartile is the median of the upper half. So my lower quartile will be 21, my upper quartile will be 44, and so the sum of those two is just 65. The sum of the four consecutive positive odd integers is 232. What value is 10 more than the smallest of the four integers? Okay, so my four positive integers, I can write it like this. Because I was asking for 10 more than the smallest, I'm gonna set the smallest equal to x just to save a little time. But here are my four odd integers, and the reason I'm increasing by 2 is because odds are only every other number. So if I add all these up, the sum of the four consecutive, I get 4x plus 12, and this equals 232. So if I solve this, I get x is equal to 55. And it wants to know what's 10 more than the smallest. Well, 55 plus 10 is just 65. Okay, what is the 21st term of the arithmetic sequence negative 13, negative 9, negative 5, negative 1? Okay, so it's an arithmetic sequence, which means all that means is that to get to the next term, you're just going to add 4, right? To get the next term, you're just going to add 4. That's all there is to it. So that's plus 4. Well, and arithmetic just means you're adding a constant. In this case, it happens to be 4. I should rephrase that. So what's the 21st term? Well, you can see to get to the second term, I'm having to add 4 once. To get to the third term, I have to add it twice. To get to the fourth term, I have to add it 3 times. So maybe you see the pattern. To get to the 21st term, I'm going to have to add 4 20 times. Right? And what am I adding that to? I'm adding that to negative 13. Negative 13 plus 80 gives us 67. I almost did my subtraction wrong. Oh, Roman numerals. Roman numerals are annoying, but it'll be okay. So we got two m's, so that's 2,569, right? LX is 60, L means 50, X is 10, and then IX is 9, plus 13, and then minus, what's this number right here? DCC, okay, so that's 800, and 50, 60, 70, 88. So what is this? 1680. Oh, so this should just be A, 1694. Okay, sweet. All right, we already did 22. If you're just joining us and you want to see the example of 22, I did it like way at the very beginning, so you can check it out there. 23, what is the value of A if the mean of A, 76, and 83 is 81? So mean, if you don't know, mean is the same thing as average. So it's basically saying the sum of A, 76, and 83 all divided by 3 gives you 81. So we just have to solve this equation. So if I multiply by 3 on both sides, then I get this, and all I have to do is subtract these two, and I get 84. I get A equals 84. The other way you could have done this, and I'm thinking about this now, you could think of the mean kind of as like compensating. So what I mean by that is, if we want a mean of 81, 76 is 5 less than that, and 83 is 2 more than that. And so right now we have like a deficiency of minus 3. And so to make up for that, we need a number that's 3 more than 81. So that would give us 84. Okay, what is the probability of rolling a pair of dice and getting a sum of 9? Oh, there is a trick for this. For the digits 1 through 7, okay, there's one trick for digits 1 through 7 and one trick for 7 through 12. If you want to find the probability of rolling a number from between 1 and 7, or maybe not the probability, but the number of ways, it's just n minus 1. So how many ways are there to roll a 7? Well, there's 6 ways. How many ways are there to roll with 5? Well, there's 4 ways. And then for 7 through 12, you'll notice I included 7 here both times. That's because the trick works for 7 on both. You just do 13 minus n. So how many ways are there to roll an 8? Well, 13 minus 8 is 5. How many ways to roll a 9? Well, 13 minus 9 is 4. So what's the probability of rolling a pair of dice and getting a sum of 9? Well, 13 minus 9 is 4, divided by a total number of possibilities of 36. So you get a probability of 1/9. What is the unit rate of purchasing 9 movie tickets for $93.15? So we just divide these, right? To find dollars per movie, you just do dollars divided by movie. And I'm pretty sure you get 1035. Okay, 26. If a digit cannot repeat, how many two-digit numbers can be written using prime numbers less than 10? Digits cannot repeat. Okay, so how many digits do we have? We have 2, 3, 5, and 7. So, how many two-digit numbers can be written? Okay, so you have to use like a counting principle sort of thing here. So we basically have 2 blanks, and these are like um, the two places. So this is your tens place, and this is your ones place. So we need to pick 2 of these numbers to be you need to pick 2 of these numbers to be like in our number. Does that make sense? Pick 2 of these digits to be in our number. So to do that, we have to use combinations, right? That's going to be 4 choose 2. 4 choose 2 is the same thing as 4 factorial over 2 factorial times 4 minus 2 factorial. If you're not familiar with that, then there's lots of other places where you can check that out. But the gist of it is, this is going to give you 6, which means that out of these 4 digits, there's 6 ways that you can pick 2 of them. Well, but here's the thing. Let's say you pick the numbers 2 and 3. If you pick the digits 2 and 3, well, you don't really know where to put them. You could have 23 or you could have 32. So there's actually 2 ways to do each of these. So for each one that you pick, there's 2 like permutations. And so we just have to multiply this 6 by 2 and you get 12. Okay, 2 integers in the ratio of 7 to 11 have a sum of 396. What is the greater of these 2 integers? Okay, so if they're in the ratio of 7 to 11, I'll say that one of them is equal to 7x, one of them is equal to 11x, and together they have a sum of 396. So together, 18x equals 396, so x equals 22. Oh, I could have done that. X equals 22, and so that's it. So it's saying is each of these numbers is multiplied by 22 to have this sum. Um, So what is the greater of the 2 integers? Well, it's just 22 times 11, which is 242. Okay, let's see. Still going. A base angle of an isosceles triangle measures 22 degrees. What is the measure of the vertex? So the base angles are going to be the 2 angles that are equivalent. So if I tell you that's 22, then that means this is 22. Then to find the vertex angle, well, I just know there's 180 degrees in a triangle. So 180 minus 44 gives you 136 degrees. So I didn't really draw this very well, but that's okay. Let U be the universal set and A, B, A, B, and C be the subsets of U defined as shown. Find A prime union C prime. Sorry, it's not prime, it's a complement. Find A complement union C complement intersected with B. So so this is our universal set. This is A, this is B, and this is C. So this little, this prime, this complement, basically just means, like, you basically just take all of the elements that aren't in A. So the complement of A, if A is compute, then the complement of A would just be R. Yeah, would just be R, except it's lowercase. Right? So I look at it, if it's in if it's in A, then I can't include it. But I can't just include random letters. It has to all be things that are in the universal set. And then same kind of thing with C. I can't include O, U, and E. So my set is going to include this, right? Everything that's in the universal set that's not in my C. And then B is just staying the same. So A complement union C complement is just, it's like the combination of these two. So it's like all of the elements that are in either of these. So that would be R, R from the A, and then C. Ooh, didn't mean to do that. And then C, M, P, T. And then I don't include the R because whenever you do sets, you only use each one time. And then find the intersection between that and B. So that's that. So what this symbol means, this upside down U, it just means like all the elements that are in both. It's just all the elements that are in both. So is I basically just go through checking, and if it's in both, then I include it in my set. So I have R in both. Wait. Oh, actually, never mind. Yeah, I have R in both. Do I have C in both? No. Do I have M in both? No. I have P in both? Do I have T in both? Yes, I do. And so here's my final answer, just R, P, and T. And keep in mind, these can be in any order. And so, look, just scanning, look, okay, so it's going to be C. Okay, in the picture below, square ABCD overlaps circle B as shown. E is the midpoint of AB. F is the midpoint of BC. Okay, so this basically just cuts these in half. EB and FB are both radii of B. If pi equals 3 and AB equals 24, what is the perimeter of the shape? Okay, so we're going to have two components to our perimeter. One is going to be the parts on the square, and one part is going to be the parts on the circle, on the quarter circle. So the perimeter contributed by the square, well, what does it tell us? AB equals 24. So our side length is 24. So we're going to have 24 times 2, because I have AD and DC are both like full lengths. And then because E is a midpoint, it tells E is the midpoint of AB, each of these are going to be half. So that's going to be 12, and that's going to be 12. So contributed from the square, I have 24, 24, and then these two together, 12 plus 12 is another 24. So that's 72. So then how much is contributed by the circle? So the perimeter of a full circle is 2 pi r, but if I have only 3/4, it's just going to be 3/4 of that. So it'll be 3/4 times 2. It tells us to use pi equals 3 to make our lives easier. And then what's the radius of our circle? Well, it tells us that B is the center, right? So the radius of our circle is just going to be like this right here, which is half the side of the square. So times 12. So 3/4 times 12 is 9 times 6. That's going to be 54. And then 54 plus 72 is 126. Okay, 31. We got some law of exponents going on here. One second. I need to double check something. Okay. Okay. It says simplify a to the fourth, b to the ninth squared cubed to the fourth. Okay. So this is just like some laws of exponents. So whenever you have these nested exponents like this, what you can actually do is just multiply these exponents. And so this all is the same as a to the fourth, b to the ninth, and then to the power of 2 times 3 times 4, which is 6 times 4 is 24. And then, let's see, a to the fourth, b to the ninth to the 24th. So I can separate this into 2, right, because multiplication is commutative. So a to the fourth, so 4 times 24 is 96. And then here, 9 times 24 is going to be, let's see, 180 plus 36, 216. Yep, so that gives us B. All right, Molly drew a polygon with 15 sides. How many total degrees are in Molly's polygon? So this is what I was checking the answer key for a little earlier. When it says in, this means how many like interior angles are there. So the formula for the sum of the interior angles is just 180 and times 2 fewer side lengths. So we have 15 sides, or not side lengths, 2 fewer the number of sides. So this is just going to be 180 times 13, which is 2340. Okay, what is the equation of the axis of symmetry for the graph of this quadratic? Well, if the equation of a quadratic is ax squared plus bx plus c, which we can see we're gonna have to move this around a little bit to fit that form. Then the axis of symmetry is just negative b over 2a. So negative b, negative would be negative 12, and then over 2 times, and then we see a is negative 3. And so we get just 2. Okay, what is the slope of the line passing through these points? Let's see. Okay, so slope, hopefully you're familiar with this. Slope is just your change in y divided by your change in x. Or you can write this as y2 minus y1 over x2 minus x1. So what's the difference in our y's? If I use this as 0.2 and this is 0.1, it would be, so that's 6 plus a minus 9a plus 4. That's our change in y. And then our change in x, 7 minus 3a minus 5a plus 3. And so if I go ahead and do this in the top, 6 minus 4 is 2, a minus 9a is negative 8a. And then down here, 7 minus 3 is 4, negative 3 minus 5a, that's negative 8a. So I'm not seeing that option, but I think it's because it wants me to simplify. So if I divide top and bottom by 2, sorry, I'm getting a little bit crammed in here. So if I divide top and bottom by 2, I get 1 minus 4a divided by 1 minus 2a. Nope, I did that wrong. I don't know what I was doing. 1 minus 4a, and then over 2 minus 4a. So I'm still not seeing the answer, so I'm thinking that maybe I just need to switch some things around. So if I multiply the top and bottom by negative 1, I end up with 4a minus 1 over 4a minus 2. Okay, and there we go. That gives the answer choice A. Okay, so like even when you get the right answer, sometimes whenever they ask you to solve it symbolically like this, it makes it tricky because you have to get it into the right form. Okay, if A equals this, B equals this, C equals this, what is the geometric mean of A, B, C? So if you don't know, geometric mean, like, you know how for just regular mean, like average, if you're taking the average of 2 numbers, you add them, divide by 2. Average of 3 numbers, you're adding them and dividing by 3. Well, geometric mean is kind of like that, but instead of dividing, you have roots. So if you're taking the geometric mean of 2 numbers, you multiply them and take the square root. If you're taking the geometric mean of 3 numbers, you multiply them and take the cube root. So for geometric mean of this, I'm going to get everything, I'm just going to multiply it all together. So 2 squared, I'm going to get 2 squared times 5 times 2 times 5 squared. And then to kind of fit the pattern, instead of 4 cubed, I'm actually going to write it as 2 to the 6th, just so I can combine these exponents later. So if I combine my exponents, I have 2 squared times 2 to the first times 2 to the sixth, right, which is 2 to the ninth. And then if I multiply 5 to the first times 5 squared is 5 to the third. And then the cube root of that would be the same thing as dividing all my exponents by 3. So I'll get 2 to the cube, 2 cubed times 5. And unfortunately it doesn't give it to me in this form, but I know that 2 cubed is 8 times 5 gives me 40. Oh, man. Oh, the 0.92 is a solution to which system of equations? Okay. This is kind of annoying, but okay, so actually I was thinking that you would have to solve all of them, but actually you can just plug in these numbers. So I would probably use process of elimination. I would look at each of these, find the easier equation to use, and then from there I can just eliminate it. So for A, x plus y equals 2, well that's obviously wrong, right? 9 plus 2 is 11. For this one, 2x plus y, 18, no, that's definitely wrong. For C, x minus y is 7, okay, that checks out. 5x, so 45, and then minus 14, that is not 38. Okay, so it's not C. D, 2x minus 4y, so 18 minus 8, okay, that one checks out. And then what about this one? 2x, 18 plus 4y, 8 is 26. Okay, so it's that one. So you didn't actually have to solve all these, which is nice. I wasn't expecting that. Okay, 37, we got some scientific notation. The way I like to do these is to just like solve them, like one of them solve with like the numbers out front, and then one of them solve with the exponents. So what I mean by that is I can take, so 8.4, since multiplication and division they're commutative, right? It doesn't really matter what order I do them in. I'll have 8.4 times 5, which is 42, divided by 2 is 21. And then 10 to the negative fourth times 10 to the sixth is 10 squared, divided by 10 to the 0th is just 10 squared. So I have 21 times 10 to the second, but remember I have to be in scientific notation, so I'll divide this one by 10, multiply this one by 10. So I get 2.1 times 10 to the third. All right, 38. Oh, we got some base conversions here. I wonder what the best way to do this is. I wonder if it's better to just convert everything to base 10 and then back to base 4. I wonder if that would actually be quicker. Okay, that's what we're going to do. I'm just going to convert everything to base 10. So, let's see. For converting this, this is the 0 place, the 2's place, the 4's place, the 8's place, and the 16's place. If you're not familiar with bases, then this is I think there's a video on my channel, actually, about how to convert bases, so you can go check that out. So we have, that's not the 0's place, that's the 1's place. I knew that. So this number right here would be 16 plus 8 is 24, plus 2 is 26, plus 1 is 27. And this number would be 1 plus 2 plus 4 plus 8, which is 15. So if I multiply these two, 27 times 15 should give me 405. And then I gotta convert to base 4, which is a little bit annoying, but if I use my answer choices, it makes it a little bit easier. So using my answer choices, right? I can see that in this leftmost place, I'm gonna have a 1, which using the same logic, right? If I have base 4 and I have 5 digits, this is the 4 to the 0th place, 4 to the first, 4 squared, 4 cubed, 4 to the 4th, which these are 1, 4, 16, 64, and 256. So I know that I'm going to have 1 256 that goes into this. That's nice to know. So this is 149. And then all my answer choices, no, they do not. All right, and then so next I have to find out how many 64s will go into this. So off the top of my head, I know that 2 times 64 is 128, and 3 times 64 is 192, so I'm only going to be able to fit 2 of these 64s in here. And then how many 16s do I have? Looks like only 1. So 21 minus 16 gives me 5. How many 4s will fit into that? Just 1. 5 minus 4 is 1, so I just have 1 left over. So looks like we're stuck with C. I bet there's a quicker way of doing that. I think this might have been the most straightforward way, though, the most consistent way. Okay, if f of x equals x squared plus 3x minus 8, find f of a minus 5. So I'm just going to plug in a minus 5 in here for x. That's really all you're doing, right? If you were to find f of 2, you would just plug 2 in for x. In this case, you're finding f of a minus 5. And so I'm just saying, well, this is going to be a minus 5 squared plus 3 times a minus 5 minus 8. So I have to do some expanding here. This isn't so bad. Okay, so I still only have one of my a squareds. How many a's do I have? Negative 10a plus 3 is negative 7a. And then 25 minus 15 is 10 minus 8 gives me plus 2. So here, we got C again. All right, we're on the last page, I believe. Sweet, just got to get through this one. All right, if the square root of 3x plus 1 equals x, then 3x minus 6 is equal to which of the following? Okay, so we just have to solve this equation. So subtracting 1 onto the other side, that's going to make it so I can square both sides. We do have to watch out for extraneous solutions, though. We got to be careful. That didn't draw correctly. Okay, so if I square both sides, right, I get 3x plus 1 equals x squared minus 2x plus 1. So setting this equal to 0, I get x squared, move the 3x over. Oh yeah, so 0 equals x squared minus 5x. Fair enough. Yeah, and so if I solve this, I can solve this by factoring, actually. I get x equals 0 and x equals 5. I have a feeling that this 0 is going to be extraneous, but you still have to plug it in to see. So if I plug 0 into this equation, but by extraneous, I mean that sometimes when you solve these square root equations, you'll get a value for x that's not actually true. And you'll see the reason behind that in a second. So x equals 0. If I plug that into 3x plus 1, it's just 1. Square root of 1 is just still 1, plus 1 equals 2. And 2 is not equal to 0. That doesn't work. And so we're pretty sure that 5 is going to be our solution, but we still want to check it, right? So 3x, so 15 plus 1 is 16. Yeah, it's 16. Square root of 16 is 4, plus 1 is 5. And yes, that's equal to 5. So we're good. So our solution is x equals 5, and then we just have to find out what 3x minus 6 equals. So 15 minus 6 is just going to give us 9. 41, we've got some nested fractions in here. So 1 plus 3 squared over 5. Okay, so 3 squared is 9, right? So 9 over 5, and then instead of 1, I'm going to write it as 5 over 5. Gives us 14 over 5. And then 4 divided by that. So it's going to be 4, and then dividing by fraction is the same thing as multiplying by the reciprocal. So 4 times 5/14 gives us 20 over 14, which is just 10/7. And then I want to find what 1 plus 10/7 is, which is going to be just 17/7. And once to find a minus b, 17 minus 7 just gives you 10. What value of c is necessary to solve the quadratic equation x squared minus 18x plus c equals 36 plus c by the method of completing the square? Okay, so to complete the square, all you have to do is you divide the x coefficient by 2, and then you just square the result. So 18 divided by 2 is 9, and then squared is 81. That's the whole problem. That one's pretty easy, actually. What is the perimeter of a regular hexagon with an apothem of 7 square root of 3? Alright, so the way we're going to go about doing this is just, we're going to find the side length of the hexagon, and then once we do that, it'll be pretty easy to find the perimeter, right? Because we can just multiply by 6. So, one of the most useful features of a hexagon is that if you divide them into 6 sections, they're all going to be equilateral triangles. So an apothem means this length right here is 7 square root of 3. So I'm actually going to draw this triangle a little bit bigger. Ooh, that's really bad. What's going on? Oh, my computer is taking a second. Just a minute. Oh no. Okay, we're back. We're back. Okay, so I have this triangle, and then the apothem of the hexagon would actually be the same thing as the height of this triangle. And so, if I have an equilateral triangle and I split it into 2, I'm actually going to get a 30, 60, 90. For those of you familiar with 30, 60, 90s, right? Here's one up here. Say this is 30, this is 60. If the side opposite the 30 side is x, then the side opposite the 60 side is x squared of 3, and the side opposite the right angle is just going to be 2x. The hypotenuse is just going to be 2x. So looking at this, 7 squared of 3 is analogous with my x squared of 3, right? Which means that x is just 7, right? That's just 7, which means this whole thing is just 14. So the side length of my hexagon is 14. And then it has 6 sides, and 14 times 6 equals 84. Alright, 44. Which of the following expressions is equivalent to 2a cubed plus 4a squared over 2a squared? So it looks like we have some factoring to do. So in the top, I'm going to find a common factor. Looks like that's going to be 2a squared. And then, so 2a cubed divided by 2a squared, you're just left with an a. And then here, you're just left with a 2 divided by 2a squared. And so it looks like all we're left with is just a plus 2. Okay. What is the solution to the inequality here? Okay. Before we accidentally make any dumb mistakes, you see, these two, they're both less than. They're both less than and not less than or equal to. And when you have less thans or greater thans, you're always going to have the parentheses and not the brackets. So we can immediately eliminate all of the answers that have the brackets. So solving this, let's see, I can subtract 9 from both sides. That's a quick way to start off. So negative 10 is less than negative n is less than 11. And then I have to multiply everything by negative 1. Oh, I accidentally made a mistake. This is just less than, not less than or equal to. But when you divide by negative 1, there's something that happens with inequalities, and there's like explanation behind this, but I'm trying to keep this string from being too long. If I divide both sides by negative 1 or multiply by negative 1, same thing, right? My numbers act like they're supposed to, but all my inequality signs will flip. And so rewriting this is what you end up with. Negative 11 is less than n is less than 10. And that gives you D. Okay, 46. The sum of the two linear factors of 4x squared minus 24x plus 27 is subtracted from the sum of the two linear factors of 4x squared plus 24x plus 35. what is the result? Okay, so we're going to factor both of these, unless there's a quicker way that I'm not seeing. But I'm just going to go ahead and factor them. Okay, 4x squared. What is this going to be factored? This is a little bit of the annoying part, but I just have to guess and check. Oh, okay, it's going to be 2x minus 9 and 2x minus 3. And then the other one's going to be 2x plus 5 times 2x plus 7. There we go. So the sum of these two minus the sum of these two is going to give me a constant. So what's the result? So 2x minus 9 plus 2x minus 3 gives me 4x minus 12. And then the sum of these two gives me 4x plus 12. Okay, so the difference between those is just 24. Okay, we're in the final stretch. Only 4 more. Okay, 47. If 64x plus 64y equals 65 times x plus y, and xy equals 0, or does not equal 0, what is the value of 2y over 2x? So, okay, I think I see how to do this. So if I expand out the right-hand side, like this, right? And then I get everything over onto one side. So I'm going to set the left-hand side to 0. So subtracting that over, 65x minus the 64x is just x. 65y minus 64y is just y. And so this isn't entirely useful yet, but if I take one of the y's over to the other side, I see that x is equal to negative y. And so they're just inverses of each other, right? If I multiply x by negative 1, then I'm going to get to y. So I can see in right here with my 2y over 2x, since y and x are just like additive inverses of each other, right? They're just negatives of each other. I know that y over x is just going to be negative 1, right? And then 2 divided by 2, that just cancels. And so my answer is just negative 1. Okay, 48. The sum of the square root of 2a and the square root of 18a is equal to which of the following? Okay, so we're going to do some simplifying here really quick. I'm looking at square root of 18a, and I see that I have a perfect square factor of 9 that can come out, right? So I'm going to have 3 square root of 2a. And then when I add them, now I have like terms. This is what was keeping us before. We didn't have like terms in the square root. So now I have the square root of 2a and then plus 3 times the square root of 2a, and I just end up with 4 times the square root of 2a. The way I was able to simplify this, if you didn't catch that, I basically expanded 18a to 2a times 9, which is 3 squared, which would be the same thing as this, right? Yes? And so if I just take the square root of 3 squared, I just get 3, and that's how I got that. Okay, last two. In the picture below, AP equals 9 and ABP equals 30. What's the perimeter of the rhombus? Okay, so by definition, a rhombus is going to have all equal sides. So all we really have to do is find AB and then multiply that by 4. So we can, since this is a right angle, we see that this is actually a 30, 60, 90 right triangle, like we were talking about earlier, like up here. So to find the perimeter, you just have to find AB, right? So our 30 side, I'm going to redraw this triangle just because I think it's useful. That's 30 degrees, that's 60 degrees, that's 90. Opposite the 30, that's going to be x. Opposite the 60 is that times the square root of 3. And opposite the 90 is just that times 2. So if opposite our 30 side is 9, and AB is the hypotenuse, right? That tells us that AB is just going to be 18. And then we have 4 of those, and 18 times. Ugh, it keeps doing that. Yeah, so we have those, and then 18 times 4 just gives us 72. All right, last one. Number 50. Leslie plotted the points -8, -5, and 6, -5. Actually, let's start this. Ooh, this is kind of interesting, actually. All right, so I have the points -8, -5, and B is 6, -5. Leslie reflects points A and B over the line y equals 4. So if I say that's like right there, and connects the 4 points to create this quadrilateral. Okay, so to reflect over a line, right, the thing with reflections is that distance across your reflection is going to remain equivalent. So to get from -8, -5 to y equals 4, I have to increase my y by 9. And so my point up here is going to be 4, it's going to be -8, and then 4 plus 9 is 13. So you can see that if I like take the average of these two, I end up at 4. And by kind of the same logic, right, this one up here is also going to be 13. So the idea here is, I didn't draw it correctly because I didn't anticipate it being that big of a difference. But um, the distance from -5 to 4 is 9, and so I have to preserve that distance because it's a reflection. And so this up here was 6, 13, right? 4 plus 9, -5 plus 9 is 4, 4 plus 9 is 13. There you go. So we just want to find the area of this quadrilateral. Well, you got pretty lucky because these two down here are at the same y. And so this ends up just being a rectangle, doesn't it? So this is just your basic length times width. So the length of this, -8 to 6, that's 14. The height from -5 to 13 is 18. And 14 times 18 is 252 square units. All right, we're all done. If someone wants to send something in the chat, something you want me to go back over, we got this hit at like just about an hour, so that's making pretty good time. Uh, I realize that the stream isn't like whenever I talk to you, I'm watching the stream on my phone so I can see the comments. Uh, Whenever I talk to you, there's a pretty decent delay between when I talk to you and whenever my phone, like it's actually broadcasted. And so you guys are living like a few seconds or like 15 or so seconds in the past. And so I'm gonna wait just a little bit. If you don't have any questions, can you actually type that so I know that you received it? I think I got everything covered pretty well. Hopefully I didn't make any like glaring errors. All right, we're good. Sweet. Hope you enjoyed. The channel's meant mainly for like high school content, so I'm gonna still do that primarily, but every once in a while, maybe like every other week, I'll do a stream that's like a middle school test. Hopefully that works, and then you can tell some of your other teammates or whatever people from other schools that we're doing this. Um, yeah, you got to practice now if you want to. I don't know what classification you're in, but some classifications you got to start now if you want to have a chance at state. Well, anyway, that's about that's about all. I guess we're ending the stream. See you guys.